Hello, how are we doing today? In this video, we're going to talk about radicals, or roots, as some people call them. Okay, let me give you some background. Follow my cursor, please, and you'll be following my cursor a whole lot, so just get used to following my cursor. Okay, and keep in mind, I'm going to give you some to-do problems. I'll call them you-do problems. That means I want you to do them by yourself. That will help you learn the material and reinforce what you've learned. Just listening, you don't really learn the material as deeply as you do when you both listen and work problems. So do both if you don't mind. Thank you. Now, let's assume that all variables are positive unless I just come right out and say so. And again, do the problems. So there's a danger in letting x or y or whatever variable it is be negative, particularly for even roots, not really for odd roots at all, but for even roots, but we'll go into that later. Let's just stay easy and simple for now. So the square root of x, like you remember the square root, like the square root of 9 is 3, the square root of 25 is 5. So the square root of x times the square root of x is x itself, assuming we're positive. But the square root of x plus the square root of x is just 2 times the square root of x. For example, the square root of 9 plus the square root of 9, that would be 3 plus 3 is 6. You wouldn't get 9 itself, when you add. Going back to 9 itself, you need to multiply. Like radical 9 times radical 9. When I say radical, I always mean square root, so get used to that. I'm going to use radical and square root interchangeably. So radical 9 times radical 9, that's 3 times 3. That just gives you 9 all over again. So there's that. Now, the cube root of x times the cube root of x times the cube root of x. Recall the cube root of a number, like the cube root of 8 is 2, because you have to multiply 2 by itself 3 times to get 8. So the cube root of 8 is 2. The cube root of 1,000 is 10, because 10 times 10 times 10 would give you 1,000. So the cube root of 1,000 is 10. Now the cube of 10 is 1,000, but the cube root of 1,000 is 10. Be sure to mind the word root. Okay. Now the fourth root, if you multiply the fourth root of x by itself 4 times, you get x. And again, we're assuming positivity. But if you add it to itself 4 times, you get 4 times that fourth root. And up here for the cube root, a similar thing happened. We had 3 in place of 4. And the same thing is true of any positive integer like 6 or 5 or whatever. Now, for like radicals, let's do this first. 5 radical 3 plus 8 radical 3, that's 13 radical 3. Okay, you can only do this if these match. They must be identical. You can't, for example, have a radical 3 here and a radical 6 here. We'll see later that if you have like a radical 3 here and a radical 27 here, 27 has a property about it to where you can turn radical 27 into a radical of 3. But we'll talk more about that later. In general, though, you can't do that for most numbers. Okay, so for now, let's just keep it easy. 5 radical 3 plus 8 radical 3 is 13 radical 3. Now let's do this one. 5 radical 3 times 8 radical 3. We multiply the 5 and the 8 to get 40. We multiply the square root of 3 times the square root of 3. That just gives you 3 itself. That's the very definition of the square root. And then you juxtapose by multiplication. You multiply this 40 and this 3, and you get 120. Okay, so that's how you do that. Now, how are we going to do fractional powers? X to the half power is going to be defined to be the square root of x. Like 25 to the half power would be 5. 49 to the half power would be 7. And we're doing positive x. Now, x times radical x, that's going to be, this x right here, remember, it can be thought of as x to the 1 power. Radical x is x to the half power. We're going to see in a minute, there's a rule that says we can add this 1 to this 1 half. We add the exponent 1 here to the exponent half here. 1 plus a half is 1 1/2, which is 3 halves right here. So we get x to the 3 halves when we multiply x times the square root of x. So x radical x is x to the 3 halves power. You use this in calculus a lot. Algebra as well, Now x squared in a similar fashion, x squared times radical x, that's going to be x squared times x to the half. You add 2 1/2, that's 2, well you get 2 1/2, but that's 5 halves right there, okay? So there's that. So now here are the laws. I've kind of put the cart in front of the horse by already doing some examples, but oh well. This, for any radical, this is true of not just the square root, but the cube root. Like the square root of a times the square root of b, the square root of b is radical ab. And notice that these rules are true for all roots. Like the square root of a divided by the square root of b is radical a over b, as long as b is not 0. We can't divide by 0, of course. Now, guys, it's not true in general that the sum of the radical is the radical of the sum. This is not true. This means not equal to right here. In general, I mean, there may be some special numbers where this is true, but most of the time this right here is not true right here. And that, so now, what do I mean by this sign right here? See this plus or minus symbol? That means if you choose plus here, you have to choose plus here. And if you choose minus right here, you have to choose minus right here. So this means plus or minus. And this also means plus or minus. Like radical a plus radical b does not usually equal the radical of a plus b, and radical a minus radical b does not usually equal the radical of a minus b. This means plus or minus, okay? So that's just a little notation for you. And this right here is true as long as b is not 0. If b is not 0, I mean if b is 0, we're in trouble. Nothing makes sense anyway. We can't divide by 0 on the bottom. Okay, and notice this is true for the other roots. Like the cube root of a times the cube root of b is the cube root of ab. You got to stick with the root that you pick. You can't jump from cube roots to square roots, for example. The fourth root of a times the fourth root of b is the fourth root of ab. The fifth root of a times the fifth root of b is the fifth root of ab, and so on. It's true for the other roots as well. Now, let's go down here. The nth root of x to the, we define x to the m over n power to be the nth root. The bottom is the root. The numerator top is the power. So that's the nth root of x to the m power. That's how we define a fractional power. And it's in good accord that we define it that way too. But anyway, and if we do x to the, now however, be careful, we define x to the, well really, it's only right that we define it this way. By logic, we pick the natural definition, x to the m minus n is x to the m over x to the n. In particular, if m is 0, that would be x to the negative n equals understood 1, because x to the 0 would be 1 over x to the n. So a negative exponent means reciprocal, if you recall from material that you've seen in times past in your classes. Okay, now, so this is the natural definition. Now, be careful, this is a little different. X to the m to the n, that's x to the m times n. And that's only, we define it in natural accord. It's only natural we define it this way. It'd be hard really to define it otherwise. It wouldn't be a fun endeavor if it would be possible at all. Now, notice, be careful, this equals this, but this equals this. These rules make sense. If you look at them the right way, you won't make the mistake anyway. Just be sure you don't mix up this guy with this guy, okay? And you'll be in good shape. Now, here's a rule, and it's only natural that we define it this way. The nth root of x, the whole thing to the m, is equal to the nth root of x to the m. You can drop these parentheses and bring the m inside as a power, as an exponent that is the power of x. And then again, that's how x to the m over n by its very definition is this guy right here. So these are just the laws. Just memorize them, have them handy. Like for example, the cube root. When I say the cube root, I mean the third root. The cube root of x to the 8th, that's equal to x to the 8/3. The square root is unfortunate. Really, it'd be nice for a square root if mathematicians would put that 2 right there. They just don't do it for whatever reason. I wish they would. Now, x is understood to be x to the 1 power, but now that, again, x to the half. So it makes sense to define x to the half power as the square root of x, and indeed we do. And the cube root of x is x to the 3rd power. The 4th root would be x to the 1/4 power, so on and so forth. Now, the 42nd root of x to the 5th, that would be x to the 5/42. This is just in accord with our definition of fractional powers. We define this guy right here to be this guy right here. Now, this is interesting. The 5th root of x to the 10, that's x to the 10/5. but that's just x squared. So that's nice. Now this is interesting. Now this time, this is different. This example here is not the same as this up here. We're doing the fifth root of x to the 42. Now guys, here's the trick. You want the biggest integer that is smaller than 42 and is a multiple of 5. You want the biggest multiple of 5 that is smaller than 42. That would be 40. So you break x to the 42 up as x to the 40th times x squared. That's using the law of exponents again. But now, here's the thing. This x to the 40th, what you do is you do 40 divided by 5, and that's 8. So that comes out as x to the 8th. Now, 2 divided by 5, that's not a clean integer. You don't mess with it. You just leave x squared in here. So what we've got is x to the 8th times the fifth root of x squared. Now, guys, some textbooks, they won't put the times sign there. I'm going to, because you see how sloppy this looks? I could put a space, but that looks tacky in my opinion. So out of good manners, I'm going to put the times sign and leave it there. So these two guys are joined together by multiplication. Okay, these two belong together in this particular problem anyway. So there's that. Now here is the same problem, but from a different point of view. We should get the same answer. We'd better, or we're in trouble. The fifth root of x to the 42, that's x to the 42 fifths. That's x to the 45th plus 2 fifths. Again, I'm seeking 40 because 40 is my biggest multiple of 5 that is smaller than 42. So I break up 42 as 40 plus 2. But now by the law of exponents, that's just x to the 45th times x to the 2 fifths. But 45ths is just 8, so this is just x to the 8th times x to the 2 fifths. And again, that's x to the 8th times the fifth root of x squared. By the definition of x to the 2 fifths power, x to the 2 fifths power is this guy right here. Okay. Now let's move on to the next one. 1 over x to the 42 fifths power. Now the trick is to... what would be the smallest multiple of 5 that is bigger than 42? The smallest multiple of 5 that's bigger than 42 would be 45. So I want to turn 42 into 45. I'll accomplish that additively by adding 3 to 42. So I'm going to stick, what I want to do is stick a x to the 3 fifths down here, and my whole motive is to be able to add this 3 fifths to this 42 fifths and get 45 fifths, which is going to reduce to 9. But hold the phone on that. So I stick an x to the 3 fifths down here in order to bump 42 up to 45. But if you multiply the denominator by something, you have to multiply the numerator by that same thing. So now, now by the law of exponents, I add 3 fifths to 42 fifths, and I get 45 fifths. But 45 fifths is 9. 45 divided by 5 is 9. So here's my 9 right here. And here's my x to the 3 fifths up here. But remember, x to the 3 fifths is the fifth root of x cubed. So I wanted to write it in radical form. This is exponent form. This is radical form right here. Okay, guys? Just to clarify that. Okay. Radical form. No, excuse me. Sorry. Radical form here. Exponent form here. Okay. The whole motive, let me go back to this problem before I move on. We want, it's okay to have an x term on the bottom, but we want x to be raised to an integer power. We don't want x raised to a fractional power that's not an integer. Like, we don't want x to the half on the bottom. We want just x or x squared or x to the fifth or somebody like that. We don't want x to the 5/3. We want x to the 5th or the 7th or whatever, okay? That'll be all for this video. Let's move on to the next video. Thanks. I'll see you on the next video.